In this extension of 5.2, we're going to be talking about graphing proportional relationships. Now, remember, I'm hoping you understand that you can take a t-table or values from a table and graph them. So let's just start with this. This is a table that I want you to write down. Time is x in seconds, and y is represented by height in meters. Now, more importantly than just these numbers is looking at what these numbers mean. So what do you notice is happening to your x values from 3 to 6? From 6 to 9. And from 9 to 12. Well, each time you're adding by 3. So what's happening from 2 to 4? From 4 to 6. From 6 to 8. Well, it's going up by 2. So if you actually graph this, now I'm not sure how much graphing you have been exposed to, but this graph can be made into something called a linear function or a linear equation. What we have here is quadrant 1 of a coordinate plane. Here are your x values. X values are always on their horizontal axis. Your y values are always on your vertical axis. We label time in seconds and height in meters. We also label x and y. If you graphed all of these points, now when you graph points, x is your first coordinate, y is your second coordinate. This number tells you to go left or right, depending if it's positive or negative. The y value tells you to go up or down. So if I graphed 3, my first point is 3, 2. That means I'm going to go right 3, up 2. If I graph 6, 4, I'm going to go over 6, up 4, over 9, up 6, and right 12, up 8. All of these form a line that intersect at the origin. Now, you'll notice here I color-coded all these for a reason here. If you look at your x value goes up 3. So if you look here, your x values go up 3, your y values go up 2. We add 3 for x, we add 2 for y. We add 3 for x, we add 2 for y. And this is going to lead into what we do with 8th grade standards at the end of this quarter regarding slope. So example number 1, we're going to determine whether these quantities are proportional. So let's do 2 different examples. Now I'm going to actually do all the work for you. You will need to have to graph on your homework, but I am actually going to write all this down. So if we're looking at these problems, I want you to use the graph to tell whether x and y are proportional in relationship. So what you're going to be given are just the tables. So for example, these go through every step for you. A is 2, 6, 4, 8, and 6, 10. You're going to plot each of those points on graph paper. Over 2 up 6, over 4 up 8, over 6 up 10. And you're going to follow the same pattern for your t-table on the right. 1, 2, 2, 4. Remember, x always goes first, y goes second. 2, 4, so that means right 2 up 4, and then right 3 up 6. So we have 2 separate graphs that are labeled. Now, something that you have to know, and I'm going to pinch this and make this smaller for a second, is this. You have to know what the structure it looks like, what's the importance of this graph. So here is what's important. The structure in the ratio table shows why the graph has a constant rate of change. Now, a constant rate of change, rate, there's your vocab word. Rate of change means it makes a straight line. You can use the constant rate of change to show that a graph passes through the origin. Now, if you remember, the origin is 0, 0. The graph of every proportional relationship is a line through the origin. There's your key word right there. or your key concept. It's right here, this last sentence. If you want to know if something is proportional, if it has a proportional relationship, see if it goes through 0, 0, the origin. If it doesn't, it's not proportional. If it does, it is proportional. So I'm going to enlarge this back again. Now, if we graph this, I'm going to slide this up. When we graph this, it says, is this proportional? Does this blue line here go through 0, 0? No. Therefore, the graph is a line that does not pass the origin. Therefore, x and y are not in a proportional relationship. Here, your line does go through the origin. Therefore, x and y are in a proportional relationship. So when is something a proportional relationship? When the line does what? Goes through the origin. Now in example 2, we're going to interpret the graph. This is actually one of the harder concepts that most students have, is interpreting every part of this graph and what it means. So it's going to get much harder in 7th grade with graphs, but we're going to start with the basics. This graph in purple here shows the distance traveled by the Mars rover Curiosity. And we see that's proportional to the time traveled. Why is it proportional? Because it crosses through 0, 0. I want you to interpret each plotted point in the graph. So I want you to tell me what each of these things mean. What does 0, 0 mean? What does 1, 1.5 mean? What does 3, 4.5 mean? Remember, x comma y. X represents the first number, and in this case, x is seconds. And y is the second number, which represents our vertical axis of inches. So what does 0, 0 mean? This is a rate. We're comparing two things. What does 0, 0 mean? It means right here. After 0 seconds, the rover Curiosity has gone 0 inches. So the rover goes 0 inches in 0 seconds. So what does 1 and then 1.5 mean? Well, 1 and 1.5 would mean that the rover travels 1.5 inches after 1 second, which is important because the denominator is 1, that is the unit rate. So the unit rate is 1.5 inches per second, which is telling you what? It's telling you the speed. Now lastly, three 4.5. That means the rover travels 4.5 inches in 3 seconds. Because the relationship is proportional, why? Because it's a line that goes through 0, 0. You can also use this point to find the unit rate. So you could take 4.5 inches divided by 3 seconds, and you would also get 1.5 inches per second.